The microphone is indeed working. Thank you, Ivan, for the opportunity to speak here. It's really very great and fun here, everyone. Thank you so much for your attention and for listening. Let's go. I want to talk about the importance of air quality and its impact on our health and environment. Now I can indeed easily switch slides. In general, this is absolutely a really beautiful photo from Belgrade, and you can clearly see the Danube in the mist. There are also beautiful scenic and picturesque hills stretching along the Danube, but they are indeed blurry because air quality is an extremely significant issue for Belgrade in winter. And this is not an illusion or fog, but data from the state network Atmospheric Pollution Monitoring. The Serbian language is still unfamiliar to me, so where there are blue circles, it's heavily polluted, and where there are red circles, it's just polluted. This is a technical term, and somewhere else there are green circles, which essentially means it's basically okay. And we usually think about air quality, especially considering our daily lives, when the air is polluted and its impact on our health. When everything is indeed good and clean, we truly care less about it. And when the air is polluted, we are concerned with two important questions. What exactly is it that has caused this situation? Who precisely is responsible for it? And when can we expect it to be clean and restored to its original state once again? In order to somehow manage and control this complex situation, we now have quite a few advanced tools and technologies at our disposal. Almost all weather information applications have a section on air quality, which is very important. Here is a photo from the AccuWeather app. Today in Belgrade, according to AccuWeather, the air is quite bad. Since many here have probably tried playing such games, where you can take a sensor, connect it to a controller, and join a large network, some community that collects data from around the world to compare whose air is more polluted. But here an interesting point arises immediately. Here I took screenshots for today from this very state network, from the very well-known AccuWeather app, and from the sensor community. And you can definitely see that their numbers are indeed all really quite different. For example, there is a parameter called PM25. Sensor community believes that in Torture today during the day it was 2, such as AltiWeather currently believes that today in Torture it was approximately 27, while the regional thing is of the opinion that in Torture it was 13, respectively. 13. There is a significant problem that needs to be addressed. The measurements are all given in micrograms per cubic meter, which indicates the concentration of a substance in the air. Geo-Orientera, the World Health Organization, believes that 15 is so-so, and 5 is absolutely clean. 35 is the threshold after which it becomes bad. This is definitely the threshold after which it indeed becomes bad. I will talk about this. Yes, if you have questions, ask. In the report, I will talk about what I usually use. Before diving into any of the technical details, I would like to take a moment to share a bit more about myself, including my background, my experiences, and the journey that has brought me to where I am today. I work at a small, innovative company called Airways, which actually grew out of a whole chain of companies that were established almost 20 years ago in the Novosibirsk Akademgorodok. The first company was Tion, which made a device for cleaning incoming air. Then, 6 years ago, the company CTA appeared, which was engaged in measuring outdoor air quality. This was important for Tion to know how good and clean the outside air was, and how much it needed to be cleaned. Recently, we created an international company called Airways with offices in various countries. And this is the Novosibirsk Akademgorodok, a view from the back. The company operates everywhere and is in demand everywhere. For example, one of our offices is located in the city of Gurugram in India, and you can see that the air is not clean. You can even see the haze. And here is this photo. And here's a photo from last year in New York. Exactly a year ago, there were forest fires, and air quality measurements were in demand there too. In general, there are problems everywhere, and to solve these problems, as management teaches, you need to measure something first. It's not exactly a universal rule. Sometimes we put too much effort into measuring and too little into solving, but generally, without measuring, you can't solve. Before we continue, I want to agree on the terms. There are two types of air. There is indoor air, which is the air we are all breathing together right now, and there is atmospheric air, which is the air outside. These two types of air are interconnected, but they have different standards, different types of pollution, and generally speaking, both need to be monitored. Indoors, it is generally easier for us to do something about air purification in our homes and offices, and more manageable. While on the other hand, outdoor air is more important because it's the air that many residents of this city breathe, which is essential for their health and well-being, especially in urban areas. Let's move on. I wanted to say that the problem is not new. When people who work on air quality give scientific lectures, they start with this remarkable treatise from 1661 by John Evelyn Esquire, who wrote a letter to the British King about the seemingly dirty air in London. And in fact, it is indeed an amazing text because it is extraordinarily well written. Truly. The problem is clearly and comprehensively laid out there. It explicitly mentions that polluted and dirty air severely affects human health. The reason for the dirty air seems to be that it appears that people are indeed burning coal. And finally, reasonable measures have been proposed in various regions to make the air cleaner, namely to remove everyone who burns coal from the city and to plant gardens. In principle, significantly better measures have not been devised yet, as of now, in any significant way. Nowadays, there are various instruments and tools for monitoring air quality. Here is an additional photo of a device from the 1970s. This is what's called Station Number 1. They can often be seen in many cities of the former Soviet bloc. It's a kind of small booth which contains an advanced aspirator that efficiently collects air samples on sorbents, and then they are carefully taken to the laboratory, and the next day you can get the detailed results. It seems the air was probably dirty yesterday, and it seems it would indeed have been worth closing the windows. But science does not stand still, and these wonderful devices have appeared which measure continuously. This booth is from the city of Abu Dhabi, which is the capital of the United Arab Emirates. Such a booth, which is quite large and heavy, weighs approximately 3 tons, and also costs a considerable amount of money. And here's another interesting thing that has started to appear in the last 10 years, the so-called sensor systems. They are smaller now, and you can hang them on any table or on any wall, get a better picture of air quality. Remember Belgrade? The air quality was uneven. Here are more details on the Trepton system. It's such a beautiful bioreactor from Moscow, where one of the container walls was transparent indeed, and it is evident that there is a separate laboratory instrument for each substance. A station like this, equipped with 3 stands, is capable of measuring approximately 10 to 15 different substances, providing detailed and accurate results for each one. And there are approximately 50 of these in total in the city of Moscow, which is exactly the capital of Russia. It's just a compact thing, a bit smaller, and it weighs only 10 kilograms. It consumes not 4 kilowatts, but 20 kilowatts, and it measures the main pollutants. The levels PM2, 5 and PM10. For indoor use, here's this device. And CO2 is not measured outdoors because it seems that the fact is that in reality, CO2 is not a pollutant or even a toxin in any way outdoors. It is interesting to measure CO2 to track everyone's carbon footprint, so it makes sense to measure CO2 outdoors. However, it is certainly more important to measure CO2 indoors because there are far more sources of CO2 there than ever before. However, data from such information sources is, in general, available very unevenly. There is a wonderful American project called OpenIQ that collects open data from around the world, and it's clear that there are many gaps. Yes, exactly. There is a slightly more radical project called QACN. It's run by the French living in China, and they don't worry about licenses. You can see that, for example, they have much more data in India. And in Latin America, much more data, and in Africa, more data, in Russia, some data, although... Oh, listen, let's talk about it. As someone who has dealt with the administrative risk of Roshidromet, I'll tell you about it later. After the report, okay? But besides the data we see on the map, there is also a lot of hidden data, and they are hidden for various reasons. Apart from legal issues, there are difficulties with data publication, quality control issues, and other challenges that are hard to overcome. As for Serbia, there is a European system for publishing air quality data, the European Quality Index. There is a presentation available there. It is evident there is not much data for Serbia. Looking at data from the official system, you see there are many more stations. And there is also a wonderful enthusiast, a former deputy head of the local Hypnometeorological Bureau, D&L, who collects data from all sources for the Extreme Ecology Project. Highly recommended. Here, about PM2.5. PM2.5 is such a wonderful parameter, these are suspended particles. But if you see a specific particle, you generally can't say whether it will be counted as PM2.5 or not, because the definition of PM2.5 is determined through a detailed measurement method, which measures particles less than 2.5. A particle falls into the PM2.5 category if it has passed through an aerodynamic filter, cyclone, or impactor that is set so that 50% and has a diameter of less than 2.5 micrometers. 100% of the particles were completely captured by the filter, but what about exactly 50% of them? A ball which had a density of exactly 1 gram per cubic meter successfully passed through this very same filter. This is called PM2.5. It is a very complex parameter, but nevertheless it turns out that a simple optical device can quite accurately reproduce the dynamics of this parameter. In this device and many other devices, there is a small and extremely sensitive camera through which air passes and is illuminated by a laser light at a 90-degree angle. Here, we don't have many tiny particles, so the laser light is not easily visible. If you shine a laser in a dusty room, there will be a lot of scattered light. This matter is detected and correlates very well. It correlates very well, but written for them, but there's much more. For example, about temperature, humidity, and gas concentration from 15 minutes ago. And this is not written in the manual. And one of the very large parts of the work we are engaged in is restoring concentration, taking into account the dependencies on various parasitic parameters. And here I would like to share an anecdote from practice. We had a device carefully designed for monitoring environmental and atmospheric conditions in a modest and charming small district center, about 5.5 hours drive from the regional center. One device for the entire eye center, and suddenly it started showing these sharp spikes, and this substance is sulfur dioxide anhydride, with concentrations around 3,000, which is 6 times the maximum permissible concentration, MPC. That is to say, generally speaking, at the level of the MPC of sulfur dioxide, people already feel that the oxygen in their mouth becomes somewhat poor. This happens every day. Every single evening at the appointed hour, or is it just a vivid, surreal, and mysterious dream to me? And there's no way to go and see what's happening there. We definitely saw that, hey. Well, yeah, absolutely. Yes, we saw that the PSO also spikes sharply, but the suspended particles do not. Yeah, and it's very strange because when there's smoke, there are always suspended particles. In the end, we found out the solution after we had already left. Smokeless coal. There really isn't any smokeless coal at the top. And the guy was putting a barbecue grill underneath our sensor each and every evening without fail. And at night, around midnight, he would leave. Another type of device which was also discussed today is semiconductor sensors that respond well to everything. That is to CO, which can be produced if there is CO2, and to organic matter, which can decompose into CO2 and water. The problem is that all these substances, they are very different in how beneficial and harmful they are. And based on the readings from this sensor, it is very difficult to say how bad everything is. Nevertheless, these sensors exist, and by collecting as much information as possible from different such sensors, we can try to create, for example, an electronic node that might be able to better distinguish between different substances. But I'm already rushing to the end because there's not much time. However, one more data source used in the weather application is mathematical modeling. Mathematical modeling is done on different types of scales and accordingly with different approaches. In general, the simplest way is if you have a wind field, you can, in a simple manner, disperse pollutants from known sources using it. Then, if you have a city, there are tens of thousands of sources in the city. You can map them onto a grid and solve the grid equation to see which areas of the city are the dirtiest and which are the cleanest. And finally, there is an extraordinarily wonderful system that collects data on the atmospheric optical density and shows us a high-resolution and extremely detailed image of the entire world. And this image can be used as initial conditions for this other image, and then eventually lead to the decision that today, for example, we are reducing emissions at the enterprise because it seems that they will all drift towards the city. After we gathered all this valuable information from various sources, here are 3 important and insightful pieces of advice that the problem of air pollution can be addressed. Identify the main scale, which causes the most harm, and accordingly focus on it. We all breathe the same air, which is crucial for our health and well-being. This shared resource connects us all, regardless of our differences. It is our duty to protect and preserve the quality of the air, ensuring a healthier environment for ourselves and future generations. Thank you for your dedication.